Good morning, Kid One, primary, kindergarten, and first graders. This is your science class. Nice that you guys all tuned back in. See, a lot of people have been doing well on their exit tickets and sending me different messages and pictures of them doing their work. If you have any pictures that you want to send in, send them either to my email or to my phone number, and we can figure out a way to put you guys on either the next lesson or on our Google Classroom. Beautiful pictures of you guys doing our science lessons. So today we're going to be using evidence. All of us will be learning how to use evidence from the webcam observations that we used last week to evaluate models of night and day on the Earth. So we're going to be figuring out why it's night and why is it day on different places on the Earth. We're going to be seeing those different models. Our big question is here on the screen. We already finished. Our first question is, what can we see in the sky at different times? We've aced that. We're now moving on to our second question, which is, why is it daytime in some places on Earth when it is nighttime in other places? I'll read that again. Why is it daytime in some places on Earth when it is nighttime in other places? I'm going to go through our vocabulary words, some different words that we're going to be using throughout this unit and that you guys are becoming familiar with as we move through our lessons. Earth. Earth is our planet. This is where we live on. Horizon, where the ground and sky look like they meet. Model shows how something works. Pattern, something that repeats itself, like 1, 2, 1, 2, 1, 2. Rotate means to spin. Season is fall, winter, spring, summer. Cycle are repeating events. Temperature, how hot or cold. Arc is a curve. So, like I said, we're going to be looking at a different models. We're going to be using models that we're going to be able to see on the video that I'll show you, and also some models that I kind of drawn. And Mr. Jennings isn't the best artist, but I try my hardest, and I'll show you some of the artwork that I have today. So we have two different maps that we're going to look at because we're going to be figuring out which one of these Earths looks more like the Earth that we live on. So I have a flat Earth. So my flat Earth is here. This is my model. Sorry, I'll pull it up for you. This is my model of the Earth, what it might look like. I have some places pinged on here. So I have USA, which is the country we live in. We live in the continent. We live in the continent of North America, but I have USA, our country. I have the continent of Africa, which is where African Americans first were where we first were born in Africa, thousands and thousands of years ago. And I also have Russia, which are where Russians are born. So we're going to be seeing if some places are nighttime while we are in the daytime, and if some places are in the daytime while we're in the nighttime. The second model I have is a model of a globe. So in this globe, I have the same places pinged. I have Russia here. I have, it's taking me a little second here. USA here. And I also have Africa here. So I have the same places pinged on both. We're going to see which one of these is how the Earth looks. Is the Earth flat? Or is the Earth a sphere? Is it round like a globe? So we're going to be seeing which one is the one we live on a flat Earth like this, or do we live on a globe circle-shaped Earth like this one? And to do that, we're going to be using information that we've already learned about. So before we move on into this information, we're going to watch a quick video and see in this video some things that we can learn about a Earth that is flat and a Earth that is round or a sphere. So we're going to be looking to see which one is the Earth. So we actually live on one. We're going to be thinking if we live on a globe like a ball, or something flat like a piece of paper, a flat Earth, or a globe-shaped Earth. I want you to take a couple of seconds. When I say go, you're going to think about which one do you think we live on? Do we live on a globe like it's like a ball, or do you think it's flat like a piece of paper? When I say go, you're going to say which one do you think we live on? Flat, globe. Get ready, go. Can hear you. Get ready, go. Cool. So by the end of this video, we're going to have our answer to see which one of these different models is the right model that tells where we live on Earth. I want to exit out of these things. Cool. So here's our video. Make sure you tune in. We're gonna learn some things, and we'll go through our models after we watch the video.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night, every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days. And that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much.
So you may have already have an idea of which one of these models is the correct model, but good scientists always complete the investigation to see if they were right or see if they were wrong. So we're going to be doing that investigation here. So we looked at different places last week to see when it was dark on that webcam or nighttime on the webcam or daytime like us. So right now we're in the daytime, and we seen last week while we were in the daytime places that Mr. Jennings put on the globe and on the flat piece of paper were nighttime. So although USA, the country we live in, was daytime, places in like Africa or Russia was in the nighttime. And we're going to be doing that investigation here. So we have our model of the Earth, which is our flat Earth, and our globe Earth. And this will be our sun, just like before. So this is going to be our sun. We're going to look at the first model of the Earth here. So when I have the sun right in the sky, so this is the sun here. When I have it right in the sky, I can see that every place has light. But we know that some places are in the nighttime while we are in the daytime. So if this was true, the earth would mostly have light all the time, and everywhere will have daytime, and the sun, because it doesn't go anywhere, or when it the earth rotates, then everywhere will be nighttime. So we know that if the flat earth everywhere is in the daytime at the same time, it must be incorrect. I can see the USA where we live, Russia, and Africa are all in the daytime in this model. Then we all can be in the daytime at the same time. When I look at a different model, which is the globe, so the globe, I have USA here. USA is up here. So USA is here. I'll show it to you. USA is here. So when the USA has daytime, places on the opposite side of the globe are in the nighttime. And as the earth rotates around the sun, places like USA, which is now moved or turned, don't have um, daytime anymore. Now Africa is having daytime, or Russia is having daytime, while USA is on the opposite side of the earth. So we know that our earth is shaped like a globe because of this, because we know that while we are getting daytime, other places are getting nighttime, and then the earth spins or rotates around and around. So also, and this is a different part, so as the earth rotates, it also is moving around the sun, just like we saw in the video. It's moving around. So places are getting daytime, some places are getting nighttime, and this gives us the chance to go to sleep or chances to wake up and enjoy our day and enjoy some sun. So you should have an idea of what it looked, which one of these models is the right model, because we just saw them. So we're going to also draw a diagram to show what happened when the earth was under the sun. So we had our first model. So this will be our sun. Sorry, I'll draw it lower. This will be our sun. This will be our sun. We had a flat earth. The sun went down to the earth, and it made the entire earth have light. But when we saw the sun shining on the globe, while some places were in the daytime, the other half of the earth was in the nighttime. So we know that the earth that is shaped like a globe is the correct earth. If you had that, you can kiss your brain. If you now know the answer, because you can change it from our investigation, you can also kiss your brain. So that concludes our lesson for today. Your exit ticket is up next. Can't wait to see how well you guys do. See you guys later.